let's factor a polynomial. In this case, it will have multiple rational zeros. So we look at this, we try our standard techniques first. There's no GCF, you can't do grouping, none of that's going to work. So our last resort is to look at potential rational zeros. So the potential rational zeros in this case are numerator could be factors of 3, denominator can also be factors of 3. And when I make those ratios, if I have a 1 on top, I could have plus or minus 1 over 1 or plus or minus 1 over 3. If I have a 3 on top, I could have a plus or minus 3 over 1 or plus or minus 3 over 3, which is the same thing as the one that I already have here, so I don't need to write that again. So I have 6 potential rational zeros. Working ahead of time, I've already discovered that, let's see, positive 1 works. 1 is a 0, which means that x minus 1 is a factor. So we divide by it to break the problem down a little bit. So I take 3x to the 4th plus 14x cubed minus 14x squared minus 6x plus 3, and I divide by x minus 1, so I put a positive 1 out here. And when I divide, I drop my 3. And so now I can see that f of x equals x minus 1 right, times the stuff down here, which is 3x cubed plus 17x squared plus 3x minus 3. And now I need to factor this guy. So in order to do that, I try standard techniques first. There's no GCF, grouping's not going to work. You can try it because there's 4 terms, but I'm telling you it won't work. So again, you have to find potential rational zeros. Now something that's important when you have to use this idea more than once in a problem, because we already did potential rational zeros once. Any zeros you've tried before that didn't work, you don't have to try them again because they will never work. Okay? So I'll make a note of that. Zeros that don't work will never work. So you never have to test them again. But if a zero does work, for example 1 did work before, it might work again. It could be a 0 more than once, right? Its multiplicity can be higher than 1. But okay, again, the numerator for my potential rational zeros is 3, so I need my factors of 3, and my denominator should be the factors of the 3 in the front, so I get the same list that I had before. So plus or minus 1, plus or minus 1/3, plus or minus 3. 1 worked before, it doesn't work this time, I've already checked it. The only one that works this time is 1/3. So 1/3 is a 0, meaning x minus 1/3 is a factor. So that means we need to divide by x minus 1/3. Okay? So let's do that. I'm going to take 3x cubed plus 17x squared plus 3x minus 3. So in other words, I have 3, 17, 3, negative 3. I need to divide by x minus 1/3, so I put a positive 1/3 here. And then I divide. So now, at this point, I have f of x equals my x minus 1 from before. Then I have x minus 1/3, because I divided by x minus 1/3, times the stuff down here, which is 3x squared plus 18x plus 9. Okay? So we're getting closer. Now I need to factor this quadratic I did the work before the video. I'm not going to go through how to do that. It's quadratic, so we set it equal to 0. When you solve this equation, you get x equals -3 plus or minus the square root of 6. Okay? So now we can come back. If I were to factor this, I have x minus 1 times x minus 1/3 times, I have two zeros out of this, x equals -3 plus the square root of 6. So that means one of my factors is x minus -3 plus the square root of 6. I also have -3 minus the square root of 6. So one of my factors is x minus that. Now, the only problem here, if I go through all my steps of factoring, right? Let's start at the first one. Here's my first step. If I were to multiply this out, my leading coefficient is x times 3x cubed. That's 3x to the 4th. That matches what I have in my original function, so we're good there. If I were to multiply this step out, I would have x times 3x squared for my leading term. Sorry, I shouldn't say leading coefficient. My leading term is 3x to the 4th. If I multiply the first terms all here, my leading term is still 3x to the 4th, exactly what it should be. But now, in this step, my leading term is wrong. X times x times x times x is x to the 4th. I need it to be 3x to the 4th, so now I need to introduce this extra constant onto the front, which does not affect my existing factors, and it doesn't affect my x to the 4th. So now my leading term is correct, and I have factored the original polynomial because x minus 1 is linear, x minus 1/3 is linear, x minus this thing is linear, and x minus this thing is linear. So we have completely factored the original polynomial here. We just had to use potential rational zeros twice because standard techniques failed us both times.